Okay, good morning class. So today we're looking at introduction to algebra. At this point, we have looked at construction or construction of algebraic expressions. Okay. Then we looked at flow diagrams as well, not so?
Yes, sir.
Right. So today we're going to look at the examples for exercise 1. And exercise 1 is on page, sorry, exercise 2 is on page 17. Okay? And I'm doing the examples from page 16. Okay. So I'm just going to explain to you what's happening here. When we are done, we're going to write down the notes. Okay? Is that okay?
Yes,
The
sir.
reason for that is because I don't want the video to be too long. Okay? So we're looking at properties of expressions. So the first thing we're going to look at is terms. Okay? The expression x plus 3 consists of two terms. Okay? Namely x and 3. The terms of the expression are separated by positive and negative signs. Okay? Brackets and division lines forms one term. You guys understand? Alright. So, with that in mind, let's look at these examples pertaining the number of terms there are. So the question says, we are given the expression 3x plus 2y plus 1. How many terms are here? Sorry? You say 5. Why 5? What did you say? What separates terms? Let's read here again. The expression x plus 3 consists of two terms. X and 3. The terms of an expression are separated by addition and subtraction signs. Plus and minus signs, in other words. Brackets and division lines forms one term. Okay, you got it now?
Yes, sir.
So how many terms are here?
3.
3 terms. You all see that, people?
Yes, sir.
But here, we'll separate there and there. So it's 1, 2, 3 terms. Fairly simple, no?
Yes, sir.
So there are 3 terms. Okay. Let's look at the next one. We've got 4 multiplied by x multiplied by y minus 4xy. How many terms are there? Yes, Michael?
So, if this multiplication sign is supposed to form one term,
Yes. So how many terms are there?
2.
2. Absolutely. Why? Again, what separates terms?
The plus and the minus.
Plus and minus signs. So these are minus. Can you see that? So there's 1, 2 terms.
Oh.
Not O means X. X and Y. No? Sarah, you're praying for us. Huh? People, the next one. We've got 3 into A plus B.
I think it's 1. It's 2.
Why 1? Why 1 term?
Because of the bracket.
The bracket here. Let's read again the definition. The expression x plus 3 consists of two terms, namely plus and minus. Terms are, the terms of the expression are separated by positive and negative signs. Brackets and division lines forms 1 term. So how many terms are here? 1, yes.
Look, it is so confusing.
No, this is easy. Easily confusing.
Yes.
Yes, okay. 1 term. Who would like to take a shot on this one? So move it up a bit.
It's 2 times.
Why 2 terms, Michael?
Oh, am I getting yeah, 2 terms. Because the addition is separated. The
Yes, well done. Addition is separating the terms, yes? So she says 2 terms. Absolutely correct. So yeah, there's 1. And this, remember, division makes how many terms? 1 term. So here, 2 terms. Okay. So any confusion?
No.
Let's go with the next one.
3 terms.
Give everybody a chance. So you got it now, so you don't care about the rest.
Sorry.
Yes, Anna. Alright. Why 3 terms? Addition and subtraction here is. There is minus, there is plus. Plus and minus. Sorry. So there's 1, 2, 3 terms. Right, you guys got it? Last one.
2 terms.
Who says 1? Nobody. Who says 2 terms? What do you say, Michael? Don't tell me 3, please. What do you say? 2. Now why don't you anchor up? Who says 2 terms? What do you say? Yes? 1. Okay, according to the definition, what's the definition? A term is separated by?
Division, subtraction and
Addition and subtraction signs. Here is your subtraction sign. So it's 1, because of the brackets is forming 1 term. So it's going to be 2 terms. Understand, Michael? You again say yes, right? So let's ask you a couple of questions with regards to this. Let's go up here. With this in mind, the terms of an expression are separated by addition and subtraction signs. Brackets and division forms 1 term. Michael, how many terms are here? 2. And now? Is she right? Means this is 2? No. 1 term. Why 1 term? It's a bracket. Not so. Right. How many terms are there now? 2. Sorry? 1 term. And now? 1 or 2? Why 2? You're still confused? What does the rule say? Brackets and division forms 1 term. It's division, so it's 1 term. I can't separate this because it's under this division line. Yes, Michael? Do you get it now? Right, let's try again. How many times are they? 2. Two. Huh? 1, yes. Here we go. You guys understand?
Yes, sir.
Right. So let's go to the next question. The next sum says, now we're going to look at coefficients. Again, you're going to write this down at the end of the video, at the end of my explanation. Okay. Coefficient. The numerical factor. People, what do you understand when you hear a numeric?
Number.
It's a number. the numerical coefficient, the numerical factor of a term is called the coefficient. Coefficient. However, the coefficient may also contain variables. See asterisk in example, which is the first one. So let's look here. The numerical factor, the number of the term is called the coefficient. So what's the coefficient here? The 3. So it's basically the number in front of the variable is called the coefficient. You guys understand? Okay. That is 3. 5ax, the coefficient of ax is? Why are you looking so confused? That's just your look, okay? 5. What's the coefficient of b?
1.
You all agree with that?
Yeah.
Yeah? She's saying yeah. She's absolutely correct. There's no number in front of the variable. It's going to be a 1. Alright. Verstaan julle? So, if you're looking at x, what's the coefficient of x?
1.
1. What if you're looking at 6? Okay, it's coming up. What is the coefficient of b?
3.
3. What is the coefficient of a? 2. You guys understand?
Yes, sir.
So, what is the coefficient of x squared?
6.
6. What's the coefficient of x?
16. Of x is
Of x, yes.
16.
16. Who says 16?
Oh, must be minus the.
Minus 16. Remember that the sign is part of the term. So the coefficient of this number is actually negative 16.
Oh.
You guys understand? So again, what is the coefficient? The coefficient is the number factor or the numerical factor of the term. However, the coefficient can also contain variables. So it's basically the number in front. If there's a negative, the negative is part of the term. Okay? It's like, say for argument's sake, you have 1,000 rand in your account. Okay? And I have negative 1,000 rand in my account. And people ask, what's your bank balance? So the bank manager asks, what's your bank balance? Can I just say 1,000? No, because I'm in a deficit. No? I'm in the red by 1,000 rand. Alright? So you can't just leave out the negative. The negative is part of the term.
But the positive is not.
Okay? So if you write the 6 as your coefficient of x squared, okay? If it's written like that, we are assuming already, or we know that this is positive. So you don't have to say positive. However, if it's negative, we'd have to say it's negative. Okay?
Yes, sir.
So when the bank manager asks you what is your bank balance, you don't have to say 1,000, a positive 1,000. No? By saying 1,000, it then implies that is positive.
So that's if I say positive 1,000.
It's not wrong.
Oh, okay.
Okay? But it's extra, it's added information not needed. Okay? Understand? People, what is the coefficient of y?
8.
Did it say of 8 xy of xy? No. So it's just of y is going to be 8x. If the question says what is the numerical coefficient of y, it would have been 8. Why? Because the numeric says the number only. You understand? But if it just says the coefficient, then it's everything other than y. You guys understand?
Yes, sir.
So for example, if you got, say you got 6xy minus 4x squared y plus 6. What is that? Now listen carefully. What is the numerical coefficient of x, y? 6.
Positive 6.
Positive 6. What is the numerical coefficient of y?
6.
Numerical. You see, you're not listening.
6. Numerical.
Numerical is what?
Oh, 6.
Number. So the numerical coefficient of xy is 6 and the numerical coefficient of y is 6. What is the numerical coefficient of x?
6.
What's the coefficient of y?
6.
6x. What is the coefficient of x? 6y. Alright?
So even if it's after,
After, yeah. It's everything other than.
Oh, okay.
Right. Let's look at this one here. What is the numerical coefficient of x squared y?
Negative 4.
Negative 4. What's the numerical coefficient of y?
Negative 4.
Negative 4. What's the numerical coefficient of x squared?
Negative 4.
Negative 4. What's the coefficient of y?
Negative 4. Negative 4 x squared.
What? Negative 4x squared. What is the coefficient of x squared? Negative 4. How many terms are here?
2. 3, sorry.
3. What makes it 3?
Because of the minus.
There's 1, 2, 3. Simple, huh?
Yes, sir.
Okay. Am I moving too fast?
No, sir.
Okay, I'll try and move a bit faster. Okay. So, what is the coefficient, or the numerical coefficient of x?
1.
1. What's the numerical coefficient of x over 3?
1. 1 over 3.
1 over 3, nice. How do you get 1 over 3? Because if there's no number there, there's a 1.
So what's the dot triangle?
Therefore. No? Do you guys understand?
Yes.
If you see this, okay, I write that very, very seldom. That is because.
So, what is the question?
The question is, what is the coefficient of x?
Of x.
Yeah. Because you must remember that this can actually be written as, and later on you will be exposed more to this, is that this, if you got 2 over 2x over 3, what's the numerical coefficient of x here? 2 over 3. But this could also be written as 2 over 3x. There's another way of writing that. Same thing. Okay, if it's written next to it, it's considered to be on top. It belongs to the numerator. Do you understand?
Yes.
Then also, if you're now looking at x over 3, then there's a 1 there, of course, not so.
Yes.
So now, this can be written as 1 over 3x. Therefore, the numeric, the coefficient or the numerical coefficient of x is third.
And if they ask for the coefficient of x.
Coefficient of x is still a third.
But so why does the x have to be part of the numerator? Why can't it be part of
Because that's a rule. It's part of the numerator.
And so what does the upside down triangle mean?
Because.
And the
Therefore.
Therefore and because.
Yeah. But very seldom do I use, and I don't actually use that. But later on in certain textbooks, if they do explanation, they use because and therefore.
Is this the maths language?
Yeah, no, mathematical notation. Okay. That girl is getting a sleep in for Eid already? No, you're not yet. Okay. You're wide awake. Okay. Sige, this sounds like a boring. No?
No, I'm just tired of being cold.
Oh, you're tired of being cold. Okay. Alright, any confusion here?
No, so it's actually
Very easy. People, everything in maths is very easy. Alright, so people, we now be looking at like terms. So like terms have exactly the same letters and indices. Another word for indices is exponents. Okay. Indices and exponents are basically the same thing. Examples of like terms. So you guys can think of it in, if you open your drawer at home, your top drawer, no? In your kitchen, what is normally in your top drawer?
utensils.
Yeah. In your drawer you got sauces. Oh, your utensil. Oh, I thought you said okay, so maybe you got, that sophisticated drawers. Right. But normally when you open your top drawer, you have your knives and your forks and all of those things, right? So if you're looking at your set, then you have this.
Yes.
What's his name there, no? Then here goes your forks
Yes,
and
sir.
your spoons. There's your teaspoons and your tablespoons.
Not that, sir.
And then you got your knives, your butter knives.
And the
And then
popsicle goes to the bottom.
And your small, and your what?
The popsicle goes to the bottom. The popsicle goes to the bottom.
Oh no, this goes on the side here, it's easy accessible.
Yes,
Yeah, I know. What goes here? Huh? Chopsticks?
No, the wooden spoon.
The wooden spoon is on the side. What is
Yes.
So now, so what's the bottom?
Okay.
Teaspoons.
But mine, the teaspoons go at the bottom.
But so you usually have teaspoons, the.
But if it's the case, right? So what happens is, you must look at it in that way, that when you pack the dishes away, whoever packs that away, you're going to put all the forks together, all the knives together, the butter knives and so on. Okay? So these are what we call actually light terms. Because if you're going to put a fork here where you find the tablespoons, or your teaspoon, sorry, it's going to be easily identified that you put it at the wrong place. You guys understand? So it will be obvious. So we're going to look at that being light terms. You understand? So if you're looking at, say, your spoons was A, so your spoon is A, and your forks is B. Now say for argument's sake, you have 2 spoons in your drawer and 5 forks, which is B. Okay? And you dry off the dishes, and you have, now you're going to add to the cutlery 5 spoons and 3 forks. And you put them all together. Remember, in the drawer you have 2 spoons and 5 forks. But to the lot you're adding, you dry them off, 5 spoons and 3 forks.
You're putting them all together.
You're putting now in the drawer now.
Like
Okay.
this up.
No.
Why would you make, what is wrong with you? We're innocent, we are. Oh my word. Right, so now, I cannot draw 5 forks in. But now you're adding, if we now add your spoons and the forks to the drawer, how many spoons will you have? 7 spoons, not some. Plus
8 forks.
8 forks. Can you see that, people? Now, can I add it further together? No. Even if she is that kind of girl who mixes it up and whatever, how many spoons and forks will you have after mixing it up? Still, you're going to have 7 forks and 7 spoons and 8 forks. You understand? Even if you now decide you're going to move, you take all your spoons and forks out of that drawer and you put it in a carrier bag. No? With your black bag, and you shake it up and all of those things. At the end of the day, you open the bag, you still got to see 7 spoons and
8 forks.
8 forks. So this is what we call 2A and 5A, we call them light terms. You understand? And then 5B and
3B.
3B are also what we call light terms. So what is 2A to 5B then?
Unlike.
Unlike terms. You guys understand?
Yes.
Simple, no?
Yes.
So that is what we call light terms. So let's read what they say here again. Light terms have exactly the same letters and exponents. Okay. So here you got 3A, 5A, and 8A. They are all the same. Not so. And that is called light terms. You see 4p squared, p squared. If there's no number here, what number is in front of it? 1. So it's 4p squared, 1p squared and 2p squared. This makes them like terms. So if you got 4p squared, p squared and p, are those like terms? No, why not?
Because of P doesn't have a square.
This p doesn't have a square. Not so.
Yes.
There's no number there. So although that is like terms, all three is considered to be unlike. They are unlike each other. Although those two are like, this will be unlike. You guys understand? Right. So it's like, say if you had A as your spoons, and then A squared was your tablespoons. Tablespoons. Okay, so you can look at it that way. Although it looks the same, but it's not the same. Not so?
Yes, sir.
I don't know if you guys have ever eaten a orange, and then something that looks like an orange is called a grapefruit.
Yes.
No? Yeah, the offset from the outside it looks similar. Not so? Although the grapefruit is bigger, it looks it looks similar. So there again we can say maybe the oranges is P and the grapefruits are P squared. It looks similar, but it's not the same. So if you want to make an orange cake, can we put the grapefruit in?
No.
Of course not. Okay. So if you're going to add this, so you got 4p squared plus p squared plus p. Could I add that with this?
No, sir.
No. So what would this be in total?
5p squared
5p squared
plus p.
plus p. You guys understand?
So can you put 1p?
Yes, you can put 1p, no problem. We will just, when we mark it, we will think there's something wrong with you. But you certainly get your full mark, okay? We don't write the 1 if it's not needed. Okay? Verstaan julle?
But so it's not big now.
Yeah, you'll still get the full mark for it, okay?
So,
People, 4AB, 5BA, AB. They're all like this. Why is that considered like?
Because
The reason for that, give me a chance. Okay, so you're ahead of us all. If you've got A, B, say A is 4 and B is 3, then this sum would be 3 times, so 4 times 3, not so. So A is 4 and B is 3. And what's 4 times 3? 12. Not so. So let's swap this around. You got B times A. So if B is 3, so it's going to be 3 times 4. And 3 times 4 is? Same. So it's going to be AB is the same as BA. So what is 2AB plus 4AB? 2AB plus 4BA? 6AB. Doesn't matter. It can be 6AB or 6BA. However, if you look at A squared B and B squared A, let's see if this is the same. What do you think is alike or unlike?
unlike.
it's like
Hypo. Like or unlike? Like to be? Unlike. What are you saying? Like or unlike? Like, right. Let's prove you're wrong quickly.
actually.
It's wrong.
So
But anyway,
so when she
but
said
I can
unlike, so it's incorrect.
But so you're just saying like,
No, I said no.
no, when you say it's like, you must have a reason.
Okay, so I say it's like because the definition says for it to be like that's why exactly the same.
Exactly, yes.
And exactly.
Anyway, right. So you see there, the A is being squared and here's the B being squared.
But
Let's see. Right, so what is A? 4. So you got 4 squared multiplied by 3. What is 4 squared? 16 times 3. 16 times 3 is 48. So if this answer is 48, they are like, they are the same. Not so? Right. So now we go, what is B? 3. And 3 is being squared times 4. What's 3 squared?
9.
9 times 4. And 9 times 4 is not 48. It is 36.
Okay.
So is a squared b the same as b squared a?
No, sir.
Answer is no.
So,
sir, but
when
sir,
I
can I
said
at
yes,
least
when I said
Give her a chance. Yes?
Okay, sir, but can I at least get one more?
No more.
Sir, can I at least get one more? Because the definition didn't say it must equal to the same thing, but said that it must have the same letters, same indices.
Right. Now coming back to that. Coming back to your 1 mark you want. You see, if I take this, coming back by definition, if this was a squared b and the other one was b a squared,
That's fine.
then it's exactly the same. Why? Because here a is being squared and there's a being squared. So we worked that one out already. This one was 48. So let's check this one. So what is b? 3. And 3 times 4 squared, which is 3 times 16, which is 48. So in turn, we can conclude therefore, a squared b has to be equal to ba squared.
So will I get a mark
No,
for that one?
you wouldn't get a mark. Okay. But you guys understand? Right. So looking here again, it says you've got 4ab, 5ba, and ab. Like or unlike? Like. You got 2x squared y. Take note now. No? 2x squared y, 3x squared y, 5y x squared. Can you see the x is still being squared in? So it makes this. Alright, you guys understand? So with that, you should be able to do exercise 2 on page 17. Okay, tomorrow we're going to look at some simplification of terms. Okay, you all okay with that?
Yes, sir.
So I'm going to give you a chance to write this down. Alright. The full lesson can be found in the description box below.